Hey Ian, can you actually understand Mandarin? 可以，可以啊。You can understand everything. Huh? Yeah, understand. Mm. Not my movie is a very interesting choice. Actually, usually 不是 my mother tongue. Okay. No, your mother tongue, like, how come your family speak English with you? Your mother also with you? Oh, okay, okay, okay. Okay, I don't know whether English or Mandarin better. Yeah. I see. Let's see how. Okay. So there are a few things we can do today. So one thing is we discuss assignment, and then if you want, we can go through tutorial also, or you got some concept want me to clarify also can. And then I'll give you some summary and tips for your exam, for which part is important for you to do revision. And then please sign on that piece of paper. And also sign your previous attendance. If I tick you on the midterm revision, you also help me to sign it. Um, and then after the revision class, I got the FYP briefing. So so if you are interested to listen, no need to how to say commit. I didn't say you after you listen you must do FYP with me. It's not like that. It's just that I want to gather some interest or want to know your what you like or what. And then you can do decision after Arash add you into the FYP group, and then you will see list from other lecturers also. But I want to do some how to say spoiler lah. I got some pure project. I got some a bit combinatorial project, and then I got one apply project, which is I want to apply AI to some linear fitting graph finding model. Yeah. You can just pick up. Yeah, just pick up. Yeah, you can just pick up. Yeah. This fitting models like real world. Real world. We got the okay. The experiment part. Okay, this is a collaboration with engineers and ESE lecturer lah. And then they doing some biomass thing also. They burn stuff and then they measure the change of weight. And then we want to like find out the function that govern this change. And then this formula actually is the one ODE formula. And then since it's the ODE formula, right? So it's pretty hard to find the model. One approach they did was using linearization. If you learn ODE, right? You linearize it and then find a solution and then try and put back into this ODE again or see whether it fits or not. Obviously there are some error because you might think that already go through so many process, right? You need to fit and then put back again. There's a lot of place you can make error actually. So uh, we were thinking that if we can just use AI to machine learn it, and then I don't know what's the technicality, but there's some paper on it, and then let's see how we're gonna do it. Yeah. Because that lecturer is my friend, no, that's the easy answer. So that's why I asked you guys make more connection. A friend is very important. Yeah. So, yeah, that's a simple answer. Yeah. Hello. Okay. Yeah. I mean, we try to involve others, but maybe they are busy with their work. So I think this project is not as hard. Just someone need to do it. And we basically already, we already like do literature review for most of the method in the market. So at, at best they can do it is like do more tailor expansion stuff, but I don't think it's really helpful. So there's one direction is using AI also. See, I think in within Malaysia, no one have looked at it yet, I think. Mm. Yeah, yeah. And then we have some real data in hand so that we can really try it out. Yeah, actually this is a extension of what we did before, lah. So we try to like extend to this area. I actually uploaded their thesis online also on Moodle also on a section apply math section. Okay. Anyway, later we can go in details. All right. So let's discuss assignment first. So later, if you think there's more mark you can claim, for me. Okay, please sign your attendance, and then your midterm assignment also please sign it. Sorry, midterm revision. Okay. Right. So we haven't discussed 8, 9, 10, right? So we'll do 8, 9, 10 in sequence. So our first question is, we have, am I showing? Okay. Uh, okay. Right. So first question is show that this space is complete. Okay, vector space of bounded sequence of real number. Okay, one thing I want to remind you, also for your exam tips, right? Make sure you answer question from definition. So try to deduce everything from definition and then try to think about definition, what thing you want to look for. Okay, from there you will find your solution. Okay, yeah. Don't be afraid if you see the question, you don't know how to like how to think about the solution in one go, right? So just write down all the definition and then I will assure you that you will see what you need to do. Even if you don't know, you can really work it out or not, but at least you will know what you need to do. Okay. So if you write down what you need to do and then what's the path to finish, you will already get most of the mark if you didn't write down the detail. Okay. So this is how a pure max works. Anyone haven't signed yet? Xiao Ye signed already. Okay, pass go she. Sorry. Okay, so question this assignment is a bit tricky because it's not just looking at sequence, it's looking at sequence of sequence. Okay, so this is the fun part of this assignment. So first part A, right, is to show that this L infinity is complete. Okay, complete means what? You need to check that every Cauchy sequence converges to a limit inside the space itself. Okay, so in that case, I will need to know what's this space. So this space are basically formed by bounded sequence of real number. But how are they bounded? Actually bounded by this norm here. So you need to understand what this norm means. Supremum of modulus xi less than infinity. So what does this mean? So the absolute xi actually is something that you should know. This is the Euclidean norm. Okay, so basically you just take your xi and then compute the absolute value. And then you look at the supremum. Okay, so you compare all the xi. And then the supremum must be less than infinity. Okay, so why not I put maximum here? What's the difference between supremum and maximum? So supremum is something that you might not achieve, right? Might not achieve. Can see, might not achieve, right? But it's can you think of it as a limit or not? Okay, if you arrange your xi properly, then it's really a limit of a sequence. But supremum is a nice way to talk about when this sequence don't I mean this set of elements don't have sequence. No need to arrange them. Okay, you just look at the sup. Okay. Right. Okay, so how to solve this question? Basically, you need to start with a Cauchy sequence in this space of L infinity. But if you compute the distance between xn and xm, which is Cauchy, right? It makes sure that the supremum of xni smi is less than epsilon. Okay, so to do this question, I think you need to also draw it actually, somehow draw it. So what's the picture you should have here? So what's my notation here? So we have x1, x2, right? Okay, and then so on. Okay, and then x1 is x11, x21, x31, blah blah blah. And then x22, x12, sorry, x22, x32, and then blah blah blah. Okay, okay, depend on your notation, but I use the superscript as the sequence, and then I use the superscript and what script? Subscript and subscript as a sequence of sequence. Okay, depend on your notation. And this is my notation. Okay, so you can see that the superscript is going horizontally, and then the subscript is going vertically. Okay, but if you look at the norm here, what are you comparing here actually? Actually, you are comparing the vertical distance here. Okay, it makes sense, right? Because you take the horizontal sequence here and then take the difference between them. Okay, then you take the sup of them. Okay, take the sup of them. Sorry, first coordinate. First coordinate. Coordinate by coordinate. If that's what you want to say. Coordinate by coordinate. Okay. So meaning you already identify one of it is like the largest one should be less than epsilon. Obviously, all the rest should be less than epsilon already. Makes sense? Okay. So actually this sup, right, actually capture the distance between every coordinate. Okay? Distance between every coordinate. So in this case here, you can deduce that every coordinate actually is a Cauchy sequence. Okay, every coordinate is actually a Cauchy sequence here. Okay, so that's how you build this limit term here. Okay, what do I call the limit term as? I call it just x1, x2, s3, and blah blah blah, without a subscript. Okay, so do I give it a name? Yeah, I give it an x hat. Okay, but now then what do you need to check now? Okay, I propose a limit. Then you need to show that because complete need to show the limit actually live inside the space. So there are two things to show here. So one thing is this limit here actually is a bounded sequence. Okay. Second thing to show is, hey, I haven't really shown you this sequence of sequence really converge to this sequence in the L infinity norm. Okay, actually I haven't do that. So there are two things you need to show here. Okay, so one thing you need to show that this limit I propose is based on a Cauchy in the real in every column. So one thing I need to show is this one live inside the space we consider L infinity. The other thing is really the convergence is happening in L infinity. Okay, there's two things you need to show here. Okay, and then the two ways to show it is using triangle inequality to justify. Okay. One thing I want to remind you is when you try to use this kind of letting m to infinity argument, right? Make sure you know what you meant. Okay, make sure you know what is really this happening here. In real analysis, right, like the Lebesgue measure stuff, you will always see this kind of argument. Okay, we won't do this epsilon in detail anymore. Okay, often you just let M to infinity, but make sure you know what this kind of argument means. Actually, it's something to do with triangle inequality. Okay. Okay. Uh. Okay. Next. Okay. B a bit tricky. Be a bit tricky. So you are given three subspace here. Whether they are closed or not. So closed means what? What does closed mean? If a sequence converges, the limit point must be inside that space. Okay. No matter it's Cauchy or what. Okay. If it converges, then that limit must live inside there. Okay. So part one got what technical problem here? Okay. So if you look at the solution I post out, right? There's some where they use here. So okay. So first you assume that the xn converge to x. Okay. So this is a space of convergence sequence. Space of convergence sequence means what? Every horizontal sequence is actually a convergent sequence. Okay, so it converges to some point. Okay, in particular. Okay. And then assume that this sequence of sequence, right, converge to another sequence. Okay. In L infinity here. So what's the thing you need to show here? Okay, so we actually uses the fact that we know L infinity is complete to actually see that this convergence sequence is actually Cauchy. Okay. Yeah. Okay. So the way we bound this is, I think most of you just bound with three terms. Okay, but the way it is done here is what's the way you done here? Sorry, okay. So back up a bit. So what we are left to show is this limit here actually live inside L infinity. Okay, so you want to show that this limit here actually is living inside C, okay, which is a space of convergence sequence. Okay, so actually we want to show that this limit here is a convergence sequence. But how to show it? We show it by showing that it is a Cauchy sequence. Yeah. Okay, so the way we do in this solution is very special. Okay, so how do we show this is a Cauchy sequence? Obviously, you need to take random 2ij, okay, compute the distance, and then say that you can make it as small as you like. So there are four things we can make it as small as I like. Okay, so first thing is the relation between the limit terms here with the term in the sequence of sequence. Okay, and then we can relate this term of sequence to its limit. Okay, and then using this limit point here, go back to the other j term. Okay, the other j term in the sequence of sequence, and then relate back to the term in the limit. Okay, but I think most of you is just doing this three of them because you're using that this convergence sequence is Cauchy. But make sure you choose the right end. Some of you don't know how to choose the right end because there's three choices here, right? Okay, you need to choose the right end, maximum, right? Maximum of end that all these things happen. Okay. Okay. I think two is okay. Two, most of you is correct. Two is easier. Okay, and then three, you just need to come out with a counter examples. Okay. So you want to show that the space of a sequence with which are eventually zero is not closed, because you can create a sequence that converge to something that's not eventually zero. Okay, although each term is eventually zero, but they converge to something that's not eventually zero. Okay. Oh, by the way, I think it is in this assignment that I changed the allocation of mark a little bit because I found that question 2 actually don't need so many marks. So I move it to 1C. 1C actually need more marks. Yeah, there's more thing to do. Okay, so I move 2 marks to 1C. So 1C, each of them will be 3 marks. Okay, how about 1C? 1C show that the following subset are sequentially compact or compact. Okay, first is so this I think this question is you need to make sense of all these sign. Okay, I think this is the most tricky part. For part so for set A, right, it makes sure that all xj such that j up to k term here, the length should be less than or equal to 1. Okay. So some of you put 1. I think okay. Okay. But the answer here just pick 0 for easier example here. But you can find a sequence that is not bounded. Okay, so if it's not bounded, then you cannot be compared. Okay, and then B. Okay, B, a lot of you use this homomorphism way, right? Isomorphism way, right? So you just isomorphic to something that's compact. But one thing I want you to note here is how do we show this unit ball is compact? Actually, it is happened in the Euclidean norm, right? Or the L2. So you need to tell me like why L2 compactness can be explained as L infinity compactness. Actually, they are equivalent. That's I think one of your assignment, if I'm not wrong. We show that those metric are equivalent. Okay, so that you can talk about compactness in both way. Okay, three, 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 three. Do you understand what's three here? If L infinity is if this how to say this vector space here is not an infinite sequence, a finite point, then this is just a closed unit ball, right? Okay, but this one is infinite sequence here, okay, with length less than equals to 1, whether it's compact or not. It seems to be compact. It's, I mean, like, seemingly compact, right? You got infinite terms, right? And then your, seems like the length is quite short, should be compact, okay? But it turns out that there's one sequence that doesn't have a convergent subsequence, which you can just randomly move this one. Okay. Yeah. Right. So you got infinite many term of, but you bound it as one. You might think that it's compact because so many term bound by one only, but it turns out that it's not compact. Because you can find a sequence that have no convergent subsequence. Okay, I think two show that a symmetric space is complete if and only if every Cauchy sequence of xn satisfy this special condition where consecutive term here should be less than 2 to the minus n. Okay. Actually, this question, right, I could easily give to MA1 actually. Or yeah, sure. I think we did complete there. So this is not very tricky, I think. So what the technique used here is first direction, you actually need to use the geometric sum. Okay. The other direction is just really picking a subsequence And then realize that a Cauchy sequence with a convergent subsequence have the same limit, converge as well. Okay, then that's it. Yeah, I think most of you doing fine in this question. Yeah. So in this assignment, actually, what I catch you is how you use your how you do your epsilon delta argument, and then how you pick n, how you bound. Yeah. Okay. Any question on this part? Yeah.
问你改
啊？你看不我改吗？啊？你要现在问还是等一下问
没有，
？OK。
我觉得你看不懂我的 notation。
可能
这是你讲 horizontal direction 啊，这个就是 horizontal direction。这个是一个 element 来的，它没有箭头。
XM 去到 X 哦。
对啊，你看 x and m 是这个，我 fix 一个 m，fix 一个 m，虽然是一条，然
哦。
后它横着去是 converge。你应该误会成我讲数字。
OK，等一下我看一下。我有扣你分咩？
呀，这题要是3个，这应该是一个。
OK OK OK，等一下我看一下啊。OK，
notation
可能
太
我看错了。
乱了，这个题目
对，
头痛。
OK，how about assignment 9? I think assignment 9, 1, 2 is okay. But I think 1, 2 is quite important if you want to note it. Exam will have something about totally bounded stuff and then continuity. 2, for 2, for question 2, a lot of you pass by using Lindelof, right? Lindelof is hereditary, right? So you try to use that. I think that's fine, but you can try and read this argument here. Yeah. So basically it's similar, okay? So you start from a countable basis and then you start from any random basis. And then you try to squeeze this random basis in between countable basis here. Okay. And then realize that you only need countably many bases from B to get another basis. Okay, from your original B basis here. Okay, and then this countability here actually obtained from the countability of C. Okay, the countable basis.
totally bounded
Yep.
是 hereditary
it's totally bounded hereditary. Did we prove it or not? I think it is. Wait, let me think. It should be, right? Should be, should be, but I'm not sure we prove it or not. Yeah. Compactness is not, huh?
compactness is not. 这个 totally bounded.
Yeah, so what's the problem here is you could get your limit away, then it becomes not compact. But boundedness should be fine. Okay, question 3, prove that a compact metric space is separable and second countable. Okay, so basically you need to find a set of countable, what separable means about again. Countable, what separable? Separable is what?
separable 有很多，
什么叫很多？
不是有 T 吗？
不是那个 not that kind of separation. This is separable, right? Huh? No, that's separation. Yes, countable then subset, good. So you need to find a countable subset that is dense. Okay, so this denseness here actually provided by the totally bounded metric space. So why do you have totally boundedness here? Because your space is compact. Okay, so you have totally bounded. So this is the thing that provide you the dense set. Actually, this dense set is quite big, you know. I'm taking all the SNJ based on the N, you know. It's not a single radius I take the countable thing. Okay. Finite thing, totally bounded need finite or countable? Finite. Yeah, okay. So for each radius, you have finite thing, and then you take for all radius going small. But 1 over N is just countably many. Okay, so it's just a countable set. And then next, you want to show that it is actually second countable. Second countable means what? Countable basis. Okay, so actually you need to show that, oh, these things actually form a basis. Okay, this is the technical part. Yeah, the technical part I think lies in this triangle inequality here. Okay, when you want to show it is a basis. Okay, so this is assignment 9. Okay. Anything you want to ask for assignment 9? 我有扣你分啊？你想一下，为什么我要扣你分？给他想一下，我没有画起来咩？
一个是
我没有写东西咩？
一个是我懒惰菜，还有一个是
啊
错。
对，如果讲 not enough 的话，你看一下我写了什么东西，看看你有没有写漏东西。你一直看你自己的东西，肯定是想不出来嘛。如果你觉得 enough 的话，你可能就不用写嘛。所以你看一下我写了什么，你没有写什么，看一下，还是你有做到我其实要你做的东西。OK OK，how about last assignment? Okay, last assignment. Okay, question 1. Although I give 11 marks here, the solution I put for you is relatively short. You should check yourself. Okay. So first question, why most of you put Q bar is R? Because I show Q bar is R in class. So you definitely want to link back to Q. But where is the intersection happen? Even if you write down Q, where the intersection happen? It's just 0, right? Yeah, that's the set that have non-trivial intersection with everyone, right? So you can string down your set, right? Why need Q? Okay. Fancy. Fancy, why not put R? Even fancy. Huh? Okay, R is not countable, so you can choose something countable. But after you write down the argument, why not you think that you can string down the set? Correct or not? You sure, obviously you can start from Q, but after you write down the solution already, right? Why not just string down the set? I didn't take off your marks, just that I want you to know that. I didn't take off marks there. Yeah. Yeah, but yeah. Okay. How about second countable? Yeah, first countable. So 0p actually is the only basis you need to consider. But some of you also put that 0 with like 1 over n minus 1 over n. I don't know what's the point. ChatGPT tell you. Yeah. See? You see, you get fooled by ChatGPT already. Right. So, okay, it's okay. People give you this choice. You should at least check, right? Okay, how it become a basis. But if you really check, how to check? The two condition, right? Intersection condition and then that condition. You can actually figure out that, oh, actually only this is the set I need. Because every neighborhood should contain 0, right? So the intersection of them must contain 0. Or if that point is not 0, you should contain that point P. Let's call it P. So these 2 points must be in there. So you just build a open set to contain that 2. Hey, turns out that 2 also constitute an open set. That's it. Okay. Okay, some of you break into 2 cases. Not necessary because due to our definition, right? If P is 0, what happened? This set actually collapse to, yeah, the set containing 0. Okay, so no need to split into 2 cases. Okay, because it's our definition on set. Okay. Finally, it is not second countable because every basis need to at least contain 0p. Okay, at least contain this. So every point must at least have this 0p, but how many of them p is uncountable already? Yeah. Okay, I think that this part everyone done okay for third part. The other 2 can be modified better. Okay. How about question 2? This is someone actually found that this is actually finer than Euclidean topology, I think. And then some of you show that it is actually a topology. Okay, so it's fine. That's fine. Prove that this tau is actually Hausdorff but not regular. And for this question, also most of you break into cases. But didn't you realize that those cases have the same solution? For those who break into cases, if you want to show off those, right? Some of you show like QQ irrational Q and then irrational. But the way you find the 2 set that's intercept empty is the same way, right? If you realize, okay. Some of you just use the normal Hausdorff to find them. Yeah. Because literally you can make your V to be empty and then you just come from the normal open set. Yeah. Okay, so there's really some relation with the usual topology. Yeah. And second, you show that it's not regular. Not regular means what? You need to find a closed set and a point. So closed set we choose here is irrational and rational point. Some of you choose rational set as your closed set. You sure? You sure that? Okay, actually you're not sure. Okay, so what argument I saw is you pick Q to be your closed set and then show that irrational is not open. Hey, 15 weeks already. Not open doesn't imply close. Okay. Close is implied by open complement. It's not open. 没有关系啊。Close 跟 not open 没有什么关系。
其实是没有，其实是不 open。
没有，我讲的是 like they want to show something is close, but show that the complement is not open. Shouldn't you show that the complement is open 呢？对啊，弄乱了。Okay, maybe it's ChatGPT 乱了。Okay, but you should teach ChatGPT. Okay. 说这 conversation 好像变很怪。Yeah, you should teach ChatGPT. 真的，你一定要跟他讲。Okay, it's not by showing the complement is not open, it's to show complement is open. 他又给你一个答案了，是不是？Yeah. Okay. So it's okay. You use ChatGPT to learn. It's okay because 你来学校学，老师也是你的 ChatGPT，对不对？ So it's the same thing, but what's different here is 不要抄 don't copy blindly. Okay. Yeah. Okay. So how to show not regular here? Actually, from the motivation to choose these 2 sets, what happens here is we know that irrational is dense in real number. Okay, so somehow this should give you the non-empty intersection here. Okay. You can read my solution, and then some of your friends actually don't give this kind of solution, but it works also. So there's no fixed way to show it, but the similarity here is we have to use the density of irrational. Okay, lastly is about the Harrison lemma, okay, as a consequence of Higgs extension theorem. So in the lecture notes, right, we use Harrison lemma to deduce Higgs extension theorem, but now we do it the other way. Okay, let's say we know Higgs extension theorem, but we don't know Harrison lemma. Can we prove it or not? So okay, some of you actually quite discreet. Okay, actually when you prove Harrison lemma, you do the two direction because the Harrison lemma we phrased in lecture note actually got if and only if, right? So, but that direction obviously is kind of trivial. Okay, if you remember, we proved in class one direction is very easy. Okay, so main thing I check here is the other direction. Is how you get this continuous extension. Okay, so obviously you need to start with some continuous function. Okay, you need to start with some continuous function. So one thing I checked you was you need to argue why the function that you define, okay, before extension is continuous. Okay, so meaning you need to check from the definition, check that every open set, the pre-image is open. Okay, but sorry. You can use testing lemma to show it because you use constant function to build it. The other way is just directly check it is continuous. Okay, because this continuity is even easier. Any inverse image of any subset is just 4 possibilities only. Okay, don't care open or not. Okay, it's just these four possibilities. Yeah. Okay. Yeah, you can use testing lemma because you start with two constant function and then join them together. Okay, but you can directly show them. Okay, once you have this continuous function, then you can use Higgs extension theorem to extend it to whole space. Okay, this is what you need to do. Okay, it turns out that you guys seems like reach your limit already. Your 8, 9, 10 is not very good. But it's okay. I think still acceptable. Your limit is like yeah, normal students should be okay. It's a normal. How to define? That's the thing that only I know. But you can take it as a compliment. Yeah.
你没有写哪里有问题？
Not a statement
这个不可能扣4分吧？
因为你没有了这个，我就不知道你怎样 prove 了。
我 prove my contradiction 啊。我说的
不是。OK，对对对，就是来没有了这句过后，就感觉就没有东西了。这种东西，前面只是在 set up 了，
对啊，
应该是这段是最重要的东西。这段我不理解做么，所以后面我也不大做。
这段我说的它 intersection 不 empty 啊。
没有，它 statement 是什么？你知道它怎么不是个 statement 吗？你两边都不是 statement，一边是 object，另外一个 object 一种 object 什么来？
就这个和这个是一样东西啊，只是我 disable 它的 intersection 吧。
那个等于那个，你的意思是？不是 if and only if，if and only if 是用在 statement 上面吗？EQ 吗？
这样有时候我们用 if only on set，
那个是有一个 statement 等于这一个，它是一个 statement。
所以来有 for all x 你左手这个就是 if only。
没有，它要一个 statement，你能够讲 true false，你可以讲 true false。
这样这个是等于啊。
如果你刚才那样子讲的话是等于啦，那等于过后
等于啊，
怎样？
等于过后你可以发现这个 non empty 啊，这个右边的是 non empty 的。
A 等于我想想，这等于对吗？哦，你只是 distribute 吧。
啊，distribute 吧。
OK，好，然后 this implies that we know that U contains A。
因为 V intersect Q 肯定是在 Q，
为什么？
因为我的 A 是 irrational，V intersect Q 肯定是上下了 Q 啊，
啊，OK 呀，这个对。
它肯定在 U 里面咯。
嗯，sure，OK，OK，
然后这个 distribute for A U contains A，
嗯哼，
它 intersect 里 U 看 irrational 也是 dense 啊，
不对，
它这个是 U 跟乱七八糟直接换它，它本来就 dense。
缓下来，上下都。哦，你也
U prime 里面有 irrational 因素。U prime 里面为什么一定要有 irrational？为什么 U prime 一定要有？其实有两个情况，它可能 intersect 这个 non-empty 或者 intersect 这个 non-empty，它肯定要 intersect 一个 non-empty。有两个情况你要看，就是
dense for
I mean dense go 只是说 like 你看漏了情况，它不一定跟这个是 non-empty，它可能跟这个是 non。因为像刚才的情况嘛，我们可以选 U prime to be empty 嘛。
可是我
你要 argue 的是，不管它 intersect 哪一个，它肯定 non-empty。如果一个 empty，另外一个
有没有可能？
那两个，一个是金生，一个是 Larry。没有证过了。哪一个任意的 open set，empty set 也是个 open set。
对啊，这里说，
哦，
就这样其实包括所有这两个，对，接着打。
在 empty 啊，
对呀、对呀、对呀、对呀、对呀、
只要弄 empty OK 啊。
可以这样讲。跟你讲，它有两个情况，一个是 intersect U prime，一个是另外一个。啊，它一定要 intersect 其中一个。等于两个东西等于equal and set 啊。对啊，if and only if 是 statement，你要讲 true or false，intersection 没有对错啊。
就日本葬送了，
什么 statement 不是美国的？
没有讨论到完那个 case，就选一个 case 不好写就可以，对不对？
没有啊，你这句话就有问题啊！
对啊，没有这个等于小事嘛。
因为他觉得有问题，但是不应该扣这样多分，他觉得。
你看，我想说这个等于写
不能
only if 有错多少啊？
很大的错啊，
不能扣4分。
天大的错。
天大的错啊！
就好像我的逗号写成句号，你扣我4分，有道理吗？
可是这个情况不太一样啊。
他看什么时候的句号跟逗号吧。
如果你这个句号跟逗号不影响说，比如说上次我的 MA assignment 里面多了，
这影响
那
啊！
个谁谁谁，
这4个人都想得到我写错了，好不好？
哎，那个东西塞满了。
你扣1分2分行啊，这扣4分，太离谱了。然后你写累，
你都没有给我 extension，我都没有 check 到，你插在哪里哦？我没有 check 到哦。
我用嘴巴跟你讲了，
跟你讲不可以啦，你讲都跟你讲100次了。哎，就算 can you sign your last attendance 啊？有报告？对呀，等下人家 check 我怎样？你给我 rush 啊？
还有就是，OK，
哦，是 L1，但是我刚才讲了嘛，这个 B 是 compact 的时候，跟 L2 是 L2 来的嘛，这么 L2 会 L2 的 compactness，对
我看不懂。
对
哦，你的9，然后 totally matter 是 hereditary，然后你是不 hereditary，
什么不 hereditary？hereditary 还是不 hereditary？
我找看一下。
这个一样，因为这样解，可是我要解
哦
什么？
这个是哦是哎，喂不，这个是这个嘛，这个是这个嘛，来这两个什么关系？就是我刚才讲的那个 triangle inequality 啊，就是。
因为我只是要把里面丢进去。
对啊，你怎样可以丢进去？谁教你丢进去的？你怎样把 limit 丢进一个那个modules 里面？怎样哦？我没有 define 过，我没有看过谁这样做过。把 limit 丢进那个呃，
哪一个？没有打勾不用理他，打勾他自己打勾，聊天就可以了。
天，
对呀，
因为我
哦，你不要理他打不打勾，打勾这样不会聊。天，
你的意思就是说 limit 会 commute with 这个 norm 欸 limit 为什么会 commute with norm？limit 为什么可以 commute with norm？啊？
OK，
什么？对呀、有 proof 过没那种东西？
看我的，
嗯，喂，你们两个没有签，还觉得很低调，
啊，我不知道哎。
不是签3次 midterm
他们好像哪一些白的那一行是吧？
What？
他们不是他们去签那个
签那个 revision 那一行
midterm 那一行，
，revision，
有一个红
耶
色箭头，
耶，红色的红色的，你签了没？不，我要你签名，not 打勾，is a 签名。笔借他一下。
不可以。
OK，有人做 tutorial 吗？有人做吗？比较重要的就是我给 solution 的那些 tutorial 啊，你一定要知道，我没有给 solution 的就不会考。但是我真的很想把没有做 solution 的做出来，但是还没有空去做。如果你有做的话，你可以跟我讲
就是要给工作
哦，
给
有几个是没有走人。
啊。
哦，谢谢。
呀，
这个你要给风险就有人问。
library，
打错就是打错。
哎，你要找东西，找不进去。Yeah，so 这些 tutorial。有些我在班上，比如讲的这种 local compactness 啊，不重要。如果你真的没有时间，你就不用做了，你就不用去看了。在班上，我讲一些来 local compactness、local connectedness 啊，那些不重要，没有考啊。
所以看5个就可以不用。
Yeah，看到 local，Yeah，quotient topology 啊就不用了。
我就都讲
Roda 可以看一下
因为你讲
，quotient 我讲不用
你讲不用我嘛。
，Yeah，我讲 quotient 不用考。说如果你看到这些 assignment 的答案啊，是那种基本的 sequence conversion 啊什么之类啊，那种基本用 definition 啊，我建议你还是看一看了。这样的话，你才会比较熟那些technique 怎样用，怎样跑。
哦，你看他这个
这些就是哎，精神有问题，精神怎么样？精神
举手啊，
非常的抱歉啊，那个最后一份assignment 好像有点不太多了，虽然有跟你讲extension 啊，但可能是我没有考虑到要通知你在 Teams 还是什么的呀，你还记得吗？但是
你有发 email 给我吗？
是没有啦，但是有一次
啊，要
跟那
发 email
个
给我，
谁
如果没有的话，我没有 record 就没有了。口头上
啊
只是只是只是没有，就是要 email 给我
哦好
，OK 吗？
可以
因为不然的话没有地方插，等一下人家就来，
但是我刚刚 present
对
完
对，人家
那你有
会
没有
怎么
讲？
怎么？
你讲哦，
没有没有，
我懂我懂了，
就这些东西一定要 formal 啦，就是要either email 或者 message 咯，不然的话，如果你嘴巴讲的话，就空气吹了就飞了
OK 我明白呀，
，OK 吗
但
？OK 啊，
是有没有机会扣少一点点？哦，
你要机会扣少一
我一
点，
年呢，
我扣你多少啊？
一年年好，就一年年，
什么啊？
就一年年就好。
等一下我看一下我扣你多少分。但是我跟你讲，这个气氛其实作用不大，你相信我吗？
如果没有影响的话就 OK 了，没有关
啊，
系。
呀，应该不会影响到你，其他都是几乎要满分嘛，对不对？其实你可以 convert 一下这个气氛在几巴仙里面，其实你可以 convert 不是？
你是讲
有几份啊？有几
算分数啊？
份才满8分，10分才满，然后有48仙嘛，对不对？一个八仙是4巴仙嘛，然后你可以算一下你这个气氛是几巴仙来的，
OK
应该不
OK
会
OK
太大问题，不是？你算看
呀，对，好，我算一
啊
下。
这个我问你，
呀呀，应该不会害到你打的不好成绩啊，我觉得。
那我可能就只有8分吧，哦，最后10个。
但是呢，一定要 email 或者 message 啊，下次。
OK 好，
呀。OK，还有什么？OK，这样的话我们就进 summary 啊。哦，还是刚才有人问，其实 box topology 跟 product topology 什么差别哈？What's the difference between box topology and product topology? One way is you could use basis to talk about it. 对，basis 什么差？So naively 啊，你如果要做一个 topology for product space 啊，你应该怎么做？You know topology for each space already, so you know the open set inside each space. Then 你要 product 哦，product set is what? You take the product of open set, right? Okay, so this is the first naive way. This is what give you the box product. But what's the product topology? Is this an equivalent formulation? If and only if, is it? Wait, let me check. I know if we define product topology, then that thing will be continuous. Yeah. Okay. So, okay. 诶，怎么不进去？
蛮 class 的，用的反
Okay, so product of a continuous function is continuous, and a component of a continuous function are continuous. So a function is continuous if only if each component is continuous. This happen in product topology. Okay. And then I gave you an example that something fell in box topology, which is uh, although every component is continuous because it's an identity function, but altogether is not continuous. Okay, so this is box topology. So what is product topology? Okay, so let me write down. So let's say product space. X1 cross X2, blah, 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 blah. Okay, so basis for box topology. We will write as U1 cross U2 cross blah, blah, blah. Okay, as long as UI are open in Xi.
Actually, should you write this way because this thing only either the comfortable product, but sometimes the product may be uncomfortable.
Okay, sure. I mean, like, yeah, sure. What's the best good way to do this?
Apply notation.
Okay, sure. Okay, so we can upgrade this. Okay, so let me keep this in record. I upgraded, so I can upgrade this to general index set. So let's say lambda. Okay, we can do this. So here will become I of I lambda UI. Okay, but basis for what topology? For product topology, what's the difference? Okay, let me give you one example, and then I work out the general one for you. So one example could be, let's say, x1 cross u2 cross x3 cross x4, blah blah blah. Okay, so in other words, what do I mean here? Okay, in other words, what do I mean here? So let me write down the general form. Let's say u1 cross u2 cross u3 blah 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 blah, such that how should I put this? How should I put this? Let me think. What's the English way? Such that all okay, all okay, all UI still the same thing are open in Xi. Okay, so this is first condition, and all but finitely many UI are not Xi. Okay, can you understand this statement or not? All but finitely many UI are not Xi. All of them are Xi, but finitely many of them are not. Huh? You know this sentence? Know this phrase or not? All but finitely many. Okay, so this but will cancel with this are not. So all of them are Xi, but finitely many are not. No, still open, still open, open, still open. But what is the form here? Can you see this form here? Xi, and then finitely many of them can be random UI. But most of them have to be the whole space. Okay. All UI have to be Xi, but finitely many UI are not Xi.
所以它不可以 全部都是
Yes, it cannot be like, yeah, proper open subset. Cannot be, huh? Cannot be all of them to be proper open.
box 会比较 fine。
Yeah, so who is final? Box will be final. Box content, yeah. Yes.
final 是更大的一个考虑我用。
final 更大还是更小？
跟 you
Final contain more. 什么 ？Final define what? Yeah. More open set. Yeah, more open set. Yeah. Box. You ask whether L infinity is a box topology or not. Just now the one we discussed, the supremum. Is it box? Is it box? So Zheng Kan asked whether L infinity is a box topology or induce a box topology or product topology. Topology induced by the sup norm.
Topology is a kind of box topology.
No, they are different topology.
不能
它是不一样的，
因为
它 convergent 都
你这个条件它是
不一样，consist of 不一样的东西啊。OK， 它是 subset 吧
对
？subset 就没有不一定 subset 它的 topology 会一样啊。kind 的意思是说，like 它们 topology 是一样。So L infinity is a box or product topology or neither? Or neither? L infinity is a product set or not? You can write because can you? You can write. You just forget the sequence, then it's a product. It could be none also. It could be none, you know. Could be none, I think. Could be none also. Okay, to figure out this, actually, you need to figure out what's the you need to figure out the open ball first. So obviously the open ball here is like open ball around sequence, right? So the problem here is can you split the open ball around sequence to open ball using, in this case is Euclidean, no? And then after you split it, and then you ask yourself whether these two bases appear or not. But even if they appear, like what we discussed just now, right? It's not enough to say whether they are box or product, unless you show that, the basis is really one of them. If it is none of them, then it's not. Yeah, you need to write down the ball around the sequence and then see if you can make it into ball around every coordinate. It could be none of them. Okay, let's go to the summary. So there's one version of summary I make. So actually I compare between metric space and topology. Okay, before that is about set theory only, right? We got function, and then function is the thing between set. Okay, within the set we have some operation here, right? You can take element of intersection, union, or take product, take complement, right? And then you have functional. You ask whether it's an injection, surjection, and then bijection. And then from here you can do some axiom of choice. Then using this function, we can count things. Okay, the method that you count 1, 2, 3, 4, 5, 6 actually is a function. Okay, so we have the idea of cardinality, or you can check how big is your set is. We have finite, infinite. Okay, infinite Inside infinite, we have denumerable, uncountable. And then actually countable include one cases from finite, one cases from infinite, and then finiteness. Okay, so don't be confused. Okay, don't be confused here. Okay, so there's a natural mapping from a set to n. So the category of set actually is the same as n. Okay, and then all the rest of the idea that we introduced in this class, right, basically is come from metric space and generalized to topological space. One is a set with a metric, and then you can consider the topology, the open ball. So in the metric space, you have open ball. Then in topology, we just call it open set because it might not look as a ball anymore. Okay. And then in metric space, we have boundedness, totally bounded. In topological space, I don't think we have boundedness yet. Because if you notice when we introduce boundedness, right, we really come with metric. Okay, the ball. Okay, in metric space, we have interior, boundary, exterior, isolated point, limit point. Similarly, in topological space, we also have we will define it using open set. This is a generalization using open ball. And then we have closure of A. Closure of A in the metric space is just limit points, but in topological space, we define using set theory, intersection of all closed set. In metric space, right, we don't really have things like basis stuff, but in topological space, we are trying to find basis. Okay, it's like a vector space, but it's not quite the basis in the vector space. Don't be confused. So sometimes in the literature, they use base, not basis. Okay, yeah. Okay, so in a metric space, you have epsilon delta continuity from function. In topological space, you have open set. Okay, and then connectedness, part compactness. Okay, similarly, you have on both sides. On the topological space, you have a different compactness, which is the open cover compactness, and also connectedness. Okay. And then in metric space, we have completeness. In topological space, not quite. Okay, but what's the Cauchy sequence if you want to define it? Then there's that's the point. So if you need to define it. So there are a few important theorem you need to take notes here. There's an upgrade version. So how does the intermediate value theorem upgrade to the version in the topological space? Actually, this statement is the continuous image of connected space. Connected space is connected. Okay, like what I warned you in class, this will definitely come out in the exam. Okay, I want you to produce this connectedness proof. Extreme value theorem. Okay, so how is it upgrade to a topological version? Actually, this is a rephrase of continuous image of compact set is compact. Okay, and how about uniqueness of limit? Actually, it is about Hausdorffness. Okay, so the thing that I highlight here is the concept that definitely will come out in the exam. Okay, so you want to get yourself acquainted to this concept here. Okay, and then how about the rest? We have countability. Okay, first countable, second countable. Okay, second countable. Lindelof space separable, and then separation. Okay, don't confuse with separable. Separation here. Okay, so T1 is in particular very important. So make sure you know all the equivalent thing about T1. And then for master, maybe you can focus on this relation here. 有些事情不好说，这样清楚。Okay. 然后we have Arison lemma, Arison metrization theorem, and then this actually not important. This is the important for the set of this course, and then in future maybe you need it. But cannot ask you to produce these things in the exam. 没有。 没有说你应该要把那 theorem 变成你天天吃饭这样的感觉，也没有，yeah，所以应该要念出来，你就要知道哦，那个，yeah，对对对，类似这样。So okay, one thing I want to advise you is once you see the question, try and list down the definition first, okay, and then those definition will guide you what you need to find. OK，不要太紧张，说，哎呦，这几个字我不知道在一起做什么。但是你先把那几个字的意思写出来，OK？因为 because I don't give you cheat sheet, right? OK, and then I don't provide you, so even write down this definition will give you marks already. OK？
其实写出来不会，
什么？写出来不会？So how to get most of the mark is you give me a roadmap. Okay, how to find it. Even if you cannot write the technical part, I will give you at least half already. Yeah. No, no. Yeah, no. Okay. So this means that the exam could be, I cannot say easy lah. It's not that hard. Huh? Yes. Yes.
When you go that the definition, so it's very
I don't think so. So the point of this exam is if you don't know the definition, I mean, like, even if I gave you a definition, you just copy down, it's useless. Okay, it's like you have to know something about that definition. Okay, yeah. So it cannot be too hard. 啊，什么？
不代表
分数代表open？
不代表它 open，所以你可以给我变 open 变 close。
OK，给你 open 和 close 的。OK，但是 I'm afraid exam unit no one。
没有关系，
我们先让 exam unit 写 topology 先。
我们在小考场可以把门锁好。
你们是在小考场不是？
对啊，所以把门锁好，不会有人进来。
应该有别人一起考啊。Okay, I draw this chart for you, so you can know what to choose about your ME next time. Okay, so you can look for what's the familiar things you have did before in your first year, second year, and then how much you progress. Okay, and then see what's the thing you can continue to take, right? Okay, so this green part here, right, is just something advanced. Okay, we can make the course more advanced. And then the blue part here, actually, there's no difference with the yellow part because it's too clumsy. So you can think of it as a 3D version. Yeah, leave yourself, leave the point. Yeah. Okay.
要 lift 了，
Okay.
你算出来，
Yeah. I think this is so far what we offer here. Okay. Okay, sometimes you can treat these course as like how to say a pass? Huh? 什么 pass 呢？ Huh? Puzzle? Puzzle? Oh, puzzle. Okay. Yeah. I mean, you need to check your prerequisite before you take the course. Okay. Sometimes it's depend on the lecturer, but most of the time it's fixed by your year and I think your year basically here. It's fixed by your year. Because when they're fixed by year, that means that you need to learn everything before that year, the major core subject. Okay, this is why you need to take notes. I didn't list combinatorics. Okay, I think somewhere outside here. Okay. Yeah, you don't really need much from other part. Number theory, here. Don't need, you need divisibility. No need. Huh? You just counting. Which one? Maybe combinatorics stay outside here. Well, I mean, common denominator actually lies in like height in every courses, right? Sometimes you need to like count how many possible way, something like that. Algebraic geometry. Yeah, obviously. Yeah. So if you want, then maybe can put it the bottom here. Yeah. So this line is a pole set, pole set. So you go up. Okay, so this is a pole set. Combinatorial is something that someone do when they are baby. Don't know. Purple color. Purple color is I think that this course is could be, how to say. Okay, if you remember that I said that algebraic topology is like the top of the courses in undergraduate level, right? Then differential manifold maybe is a bit higher than that.
Then people do the matrix.
Differential geometry, depends what they did in the differential geometry course. But for here, right, I think I heard it's about Stokes theorem stuff. Did you prove it in your MA2 or not? No mention, me? You sure? I think the notes got Stokes theorem. Maybe skip lah. So it will be done in differential geometry in this case. But if it's a Riemannian geometry, then it could be harder. Yeah. Riemannian geometry meaning, okay, now given that you learn metrics already, right? So there's something called Riemannian metric. There's something mentioned by the physics master also, right? The master from physics. Yeah. So basically it's like a n-dimensional, maybe Stokes theorem stuff. I think the courses in at least in here they provide you a very good computational foundation. Okay, but there's good thing about it, there's a bad thing about it. But if you are given this chance, right, make sure you learn the foundation well, and then at the same time you ask yourself why I'm computing this. Although it is not tested, it's not in assignment, it's not exam, but you have to ask yourself, okay, why am I computing this? Why is it compute like this? Or can I compute in different way? Like that. Okay. If you just learn for the sake of computation, then you will forget one day. Easily forget. Huh? Yeah. Okay. Let's take a break. I sent something. Huh? Short break.哎，黑影你删了吗？没有哎，这份没有，你可以过来这边删。哦。
我应该会在 real analysis 上面真的用要 bright 我，如果被 bright 过来，就会被 bright 退路。
Yeah.
我问题是我不喜欢讲别的。
对对，我没有讲没有在 exam 吗？我没有讲那个东西没有在。我讲他们讲的是 quotient topology 啊，quotient 呀，包括你们也是没有
没有。
quotient topology 没有看。哎呀，金生，
不好意思，我想问一下
也
那个画太赖黄色的那个是什么意思？那也
哪个？
呃
我现在说的这个，
不是上面那些总结都不
这些
画
highlighted 的
黄
哈
哎
，highlighted 的
呀
哈
呀
，highlighted 的是会考试会考的概念。
好，谢谢。
嗯，是了。
课本上读到。
看下我，你没有发现我地面没有人，最后一个是七，一个是不懂，然后不懂。
最后一个项目我被9那个
computer 会不可能不开，因为很多人。
这不算有趣的。
那对啊，
那么对，
那个不知道，那个不确定。本来应该是这个 Seng 吧，因为有开 algebra number theory。下个是
你不是还有一个 mechanic 课？
还有另外一个项目吗？
你不能去里面听。
所有那个中午不给这个不要回家拿。如果是个谁就不叫我去。
很好啊。
诶，为什么嘉怡没有在？他不是 post？诶，洪瑞，你知道嘉怡为什么没在吗？去讲？哦，OK，他不是昨天他 post 的那个。等下我们要进什么环节哈？让你决定啊，M1啊，因为有人4点要来，所以我们不可以太早进这个环节啊。来听哦。
哦，那个 FIP 版本。
对，因为我也有教我的之前 FIP 的。Yeah.
那些考试重点也是
Yep. 啊，yes. 你们会有一点小差别吧？差别不大。你们是全部考完哦。OK，midterm 的东西你们也要看一下。你可以看一下去年的 midterm 嘛，应该会有帮助。sorry 啊，就是我给的那个 practice，midterm 的 practice 可能会有帮助。去年反正没有放出来
啊，
没有放出来，
没有打算发，
没有。
可是他就是跟你讲，跟去年反的很像。
是他讲啊，不是我讲啊，是他讲啊，不是我讲啊，OK，他讲啊，我没有讲啊。
discuss。
什么？
你写这个 S 啊？
哦，OK，
我信息。
OT
听不到。哎，我已经记录进来了，听不到，只是做一个记录吧。
不要发给他。
OK，够了。等一下，等一下。嗯，
哦，
是，
一个嘛。
哪一个是 midterm？呀，midterm。Yes，midterm。呀，还有什么 concept 你们觉得要问的，不问的？什么 concept？这门课有帮助你们理解 MA2吗？啊，没有帮助吗？
前面是有，后面就没有。
啊，应该是因为后面比较是 geometry 的东西啊，后面。
那种 integration differentiation。
对。啊，midterm 前啊 p r e OK，midterm 前啊，不要多。
但后其实没有影响。
OK，所以你觉得，所以这样子比的话，所以 General Topology 比 MA2 多了什么
是这样的。
啊？不是多了什么内容？我不要这么形容词，我要准确的东西。
细节，比如那种
比如说
很广哦。
什么事情？
，like 什么东西有 cover，什么没有 cover 啊？like 比如说啦，可能你 MA2 有没有 cover compactness、connectedness
那是没有啦。
啊，complete 没有啦。OK
然后 Vimy Point Compact 没有提过
OK
sequentially Compact 有 Vimy Point 没有。
OK，所以一种 compact 罢了啦。
两种
两种
sequentially 有，可是在MA2 里面这两个等于的，因为 Magic Face 是
sequential 跟什么？
跟 Compact 是等于的。
哦，那个 open cover 的。
对，
OK
就是它虽然有给两种定义，可是两个定义
OK
是一样的东西。
对啊，没有错。
它会证明，然后你
OK，好
觉得在后面你会发现到你做任何东西的时候
OK，
都可以用。
所以我们多了 completeness 啊，你是说
Completeness
connected 呢？
connectedness 的话就有啊，一样啊，
一样。
只是怕 connectedness 也有嘛，只是 vocally 那个没有吧。但是
OK
vocally 那个我其实也不会。
OK，
然后还有什么啊？我看一下
因为他就是想把一门变 abstract，一门算嘛。不重要。
那我是哦，是他啊，没事。
你考，你考试，我不懂啊。
嗯，
嗯，你们
懂的都
考 A
懂，就不要讲。然后
这里是
我出来这3天，
然后还有就是有一个什么，像那种什么 cut set 啊，cut point 啊，这些是没有什么。
你们还有一门是什么？
然后还有什么？哦，separate，然后你这边 separation 有一个 limit point 的定义，那 MA 都没有聊过，完全没有提过。然后还有就是你这边很多有定义，有很多是那种，对，你会先聊 topology 跟 space connected，然后你会去聊一个 space 里面的 subset connected。但是我觉得 MA2 在这个地方讲的很，就是
可是我看到你
他对
们的
subset 没有什么定义。
没有，我看到那个子轩有做一个题目是有相关的哦，
什么题目？
就是这个 connected 的时候好像是有不知道有 subspace 吗？还是他有啊？他有好像你们的 connected 那是不是有4个条件呢？
啊，
对啊，那4个条件呢？
在 MA2 里面呢，
啊，
重点 subspace，
它是直接 define for subspace，
是，所以他没有
没有 define for 整个，
对，所以其实
它直接进 subspace，
我确实
因为整个也是一个 subspace 嘛，
嗯，
所以它就呀
这样不足。
不注重不一样的 treatment 的。
然后因为这里学的时候还要分两个出来，这两个好像一样又好像不一样的感觉。
差不了多少。
对，但是就是像 subspace 的时候，这里像我那天问你嘛，就是 subspace 的时候，它还定义一个 limit point 的定义，但是 whole space 的时候就没有 limit point 这个问题去考虑了。
应该也可以吧，因为 subspace 就是整个 space 啊整个 space 也是一种 subspace，所以
有
整个 space 是一种 subspace，
对
所以整个 space 是一个 subspace，所以有的，所以是有的，整个 space 是一个 subspace。
因为像这个 lemma 2的时候，就是你这边解释就是那个 y is subspace neither which contain the point 下这嘛来，为什么你不要在一开始就提到哪一个结论出来专门讲这个？就是在讲
因为
x 为什么要到 y 的时候才突然？
因为可以一次过讲，因为 subspace cover 全部嘛，对，可以一次过讲。
那你考虑
Yeah，
然后还有一点就是它里面有一些，不懂为什么我觉得有时候他在教，他一下讲，我读回去那时候，我发现到他一下讲 topology 个 space，一下又突然间回去 matrix space，然后一下又回去 topology 个 space，
你讲那个 MN
是没？有一些地方感觉为什么
啊
有一点
啊
突然间哦，你
嗯
代表着 topology 个 space，然后突然一句matrix space is 什么什么，然后突然间又跑回去，
看一下在哪里，看一下在哪里。
那 chapter 5那边就有一点，对，是不是有很多地方还是这样子跑来跑去的？
因为有些东西是在 matrix space 里面发生的。
哦。这个 chapter 5哦都是 matrix space，
对对对，
这整个 chapter 都是
对对对对对，那个整个都是一样。
这 chapter 4还是有忘记哪里了，有一个 part 就是你一下突然间又讲这里哦就这一方的，然后他突然 matrix space，然后他突然间就 discrete matrix，然后又开始一堆 matrix，又开始突然间讲一堆 matrix space 了，然后又突然间跑回去找回去，
因为你要看一下发生在哪里。
这里有 matrix space 都对方的，然后这边又 matrix，
对对对，你要看一下他讲了什么，因为有些东西是它的 counter example 发生在 matrix space，你就不用去。
那有一些就是他你这边找不到刚才的，因为他的 matrix space 就是 true，像那个 compactness 那个那三个定义对吧？它在 matrix space 就是 true 的。
我想方面的那个事情是坏。
对，但是也有一些是属于在 matrix space 上，或者包的是 I，
大部分是 match。
所以标志还又回去 matrix space 那边跑。
那他们设计的
没有，你要看我为什么要讨论 matrix space，因为有时候它的 counter example 发生在 matrix space，我就不用讲 topology space 嘛，因为 matrix space 是一个 topology space。
是的。然后你也没搞清楚我要跑路。
读不读得出来？OK。OK。
每天4点还有谁要来？跟你3段录制。
可能进宝吧。哪里人？哪一个？瘦瘦的。不要讲金人，
你刚才讲是一个男的
男的。
或者一个女的，你这样回答你看什么反应？你刚才讲 x y，听手。
那我在讲，
哎，你只有那一个是吗 ？assignment 8哈。
还有什么9
啊，assignment 9。
poly 包的刚里面有一个你证过一个讲 subspace of 一个 totally bounded space 是对吧？
我有证过，然后我讲你要证啊。
你哪一个问号 hereditary 部分？
问几分？问几分？我有证过。
I mean 01是 subspace
鸟的
01，
为什么
我有证过，你知道吗？
有的。它不叫 hereditary，叫 totally bounded。
但是这个就无听懂就。对，你不想代表
好，这个。
两个都表出的，很多种。
对啊，但是你呀以后要筛一下，
我不表，
塞
还要买那个东西。
干，
就这个吧，这个 assignment。
后面是什么？我忘记。
这个是你的，
那你一点
8 GTN
898，
888。诶，怎么我一直按到这个？OK，这个啊，我看错了，
哎，看不懂 notation。
看错可能，因为我都排错啊，排错不是你的 M 是 fix 的吗？我的 M 是这样跑，很傻。
就是我 fix 一个 m 看它那个 fix m 的 sequence 对，obviously 它在 C 里面它 conversion。
为什么我会看错啊？给我想一下。
我说你都发错啊，你都懂。
就这个，我们大家再讲，就在讲一下。
诶，可是哦，你看哦，你的 SM 啊，我们不是去这个嘛？对，一不是去一吗？二不是去二吗？三不是去三吗？
对呀、你这个写错了，你写应该是 x 2 你写成 x1 对，
这个呢？
这一个是 sequence of sequence，
对，这样说。
这一个是一个 term 的 sequence，
嗯，
就是 xm。
这样我知道我为什么 confuse 了。I know why I confuse。因为这个 convert 去这个是在讲这个是 sequence 它 convert。因为你写 m 在这里的时候，我会认为说你在 index 这个 sequence，
啊，
你懂吗
这就是为
？unless
什么
你这样，
没有
这样啊，你就应该要这样 n 然后 n to infinity 嘛。啊，不然的话，我一定是把这个 m 拿来 to infinity 的嘛，
对呀、就是
懂吗？
这个就是 m 去 infinity 的意思啊。
你要的是这个 n。
对，所以这里面你要看清楚，我写这个的时候，它上面有那个 vector 的，我写这个没有 vector，代表这个是一个 fix m 的一个element。哎呦，干了，我们有 x1对不对？x1这个 x and n 代表这一条，然后我的 x and n 代表这一条，这个有 vector，这个没有 vector。哎，我都写好了吗？写好，我给你啊，x n m x1 n x2 n，这是一条，这是
哦，OK OK OK，可以。
因为很多人用那个 subscript superscript 好像，
我是我们的反正谁收
哪一个？哦哦哦，
就我编咯。
OK。